Hi Chem Peeps. Today we're going to talk about specific heat. And what I want to tell you that heat is the amount of energy that it requires 1 gram of substance to increase 1 degree. And so our general formula for specific heat is going to be Q, which represents heat, times the mass, times the change in temperature, times the specific heat. Now, specific heat is a constant that is that is different for different substances. So down here at the bottom, I have the specific heats for different phases of water. And real quick, I'm going to put down here the change in temperature. For those of you that don't know, is always going to be the final temperature of the substance minus the initial temperature of the substance. So looking at this first problem set here, it wants to know how much heat. So we're going to be solving for Q. For 150 grams of water when it's heated from 24 degrees Celsius to 45 degrees Celsius. And they give us the specific heat of water. So we're solving for Q. The mass is going to be 150 grams times the change in temperature. So the final temperature is 45. The initial is 24 degrees Celsius, and the specific heat is 4.184 joules per gram Celsius. And of course, if we multiply this out, the change in temperature here is going to be 21 degrees Celsius. So when we multiply Q, the amount of heat that it requires to make this change is going to be 13,179 0.6, that's what my calculator gave me, joules. Now, if I look at the amount of sig figs, 2 sig figs is my least amount, so I would round this to 13,000 joules of heat. Now let's go over to the other problem. The other problem is a little unique because we're taking a piece of metal, getting it really hot. So this is its initial temperature of 108.7 degrees Celsius. Then we're going to move it into a calorimeter with 1,400 grams of water, whose initial temperature is 25 degrees. And then they come out with an equilibrium or a final temperature that they're equal to of T final of 28 degrees. Now, what we're going to do is take the concept of this equation and use it, because one substance is losing heat, one is gaining. The one that's losing, qlost, is always going to have a negative in front of it because the change in temperature is going to be negative. It equals a positive qgained. So in this example, the loss is going to be the aluminum and the gain is going to be the water. And so what we're going to do is we're going to take this equation and set it equal to each other. So a negative mass times change in temperature times specific heat is going to equal a positive mass times change in temperature times specific heat. So if I look at the mass of aluminum, it's 45.7 grams. The change in temperature is going to be the 28.2 degrees Celsius minus that 108.7 degrees Celsius. And then, of course, we don't know its specific heat. That's what we're solving for. This change is actually going to be a negative 80.5 degrees Celsius. And so that this negative of a negative will make this side positive. That equals the 1,400 grams of water times the change in temperature, so 28.2 minus its initial temperature of 25.4 degrees Celsius times its specific heat. Now this is water. We know the specific heat of water from the last problem was 4.184 joules per gram degree. Now, real quick as a side note, sometimes when you get these constants off a chart, instead of Celsius here, it might have Kelvin, and that is okay. Kelvin will never equal Celsius, but the change in Kelvin will equal the change in Celsius. So even if this had been Kelvin down here, that would be okay. because we're looking at the change, not the actual temperature. Okay, so let's go back to our problem. If I reduce the left side, I'm going to get 3679 grams Celsius times X equals this other side, which is going to be 16,386 joules. And so the specific heat, X is going to be the specific heat of aluminum, and that's going to come out to be 4.45 joules per gram Celsius or gram Kelvin, whichever one you want to use. And so that's how we use the formula for specific heat. Now find my second video, because I'm going to take water at its below freezing and take it all the way above boiling, and that takes several steps. So check me out there. You can find me on TikTok and YouTube at Kim's Kim Chat. Talk to you later.